Hey y'all, my second theory video in numerical methods, and this time we're going to talk about the secant method, which also estimates zeros like Newton's method. But the secant method has two advantages. One is that it does not require that our curve be differentiable, and second is that it always works. Newton's method sometimes fails. Yeah? Cool. So I think these are great advantages. One drawback is that the secant method is a little bit less efficient in getting to the estimate. Or getting to the same degree of accuracy. So it takes longer basically. But you're programming it, so the computer is doing the work, and so that's fine, right? That's not really a drawback. All right, cool. So how does it work, right? Well, this is how it works. So you take 2 points, and so this time you require 2 x values as opposed to Newton's method where we only required 1 x value to start, right? So we have 2 x values to start, and we take the points corresponding to those x values on the function. So in other words, x1 and f of x1 and x2 and f of x2. We connect them to draw our very first secant line. And yes, I am foreshadowing that we'll have more secant lines. So the actual zero we're trying to estimate is this point right here, and let's call it A. And so our very first estimate using our very first secant line, so our estimate of A, the very first one, is going to be this point here. Let's call it x hat. Yeah? Okay, cool. So what are we going to do? Well, we're going to evaluate the function at x hat and then decide whether or not the function's value at x hat is positive or negative. Clearly, this time, the function's value at x hat is negative, and it's some negative value over here. And all we care about is whether or not it's positive or negative. Yeah? Cool. Since the function's value at x hat is negative, we're going to replace x1 with x hat. And so now we're going to use this point and this other point we already had to draw a second secant line. You guessed it. And so that second secant line, which I'll draw in red, will look like this. And there we go. And so our new estimate of A is going to be this point right there, this point right here, which clearly is much closer to A. And so each iteration, in other words, each secant line, repeated secant line, is going to give you a better and better estimate of A. And let's say that this point, the second estimate, is called x hat hat. So as you can see, using an iterative process like this, in this manner, you can get an estimate of A that is as accurate as you'd like, right? And so you could set a requirement. For example, you could require that the value of x hat hat, or however many hats you put on, so however many iterations you use, you can require that your estimate have a y value as close to 0 as possible, right? Not as close to 0 as possible, but as close to 0 as you would like. So yeah, so you could just set a requirement and be like, be 10 to the negative 5 within 10 to the negative 5 of 0 or whatever. So I'll show you how to do that when we're programming it in Mathematica. But this is basically the theoretical explanation, and now we should, just like we did in Newton's method, work on getting that big formula that's going to go in the body of our program. Yeah? Cool. So to do that, we're going to focus on our very first secant line and figure out the equation to that very first secant line. We're using this point and this point, so the slope is going to be, from good old algebra, f of x2 minus f of x1. This is simple, right? Divided by x2 minus x1. I taught this to my Algebra 1 students. I have a very smart bunch, but I taught it to them and they got it, so you should be able to get this if you're in numerical methods. And I'm sorry, I don't mean to make you feel bad if you don't get it. Hopefully, I've explained it well enough. Anyway, we've got the slope of that first secant line, and so we need a point, and let's use the point x1 comma f of x1. And so using the point and the slope, we can write the equation of that secant line in point slope form. And that equation is going to be in point slope form, y minus f of x1 is equal to m, the slope we already calculated, or yeah, we didn't calculate it, but whatever, you get what I'm trying to say. X minus x1. And so to get to x hat, our very first estimate, we just need to solve for this x, yeah? And obviously solve for this x after setting y equal to 0. Because, yeah, this x hat is a 0 of that secant line. So, therefore, y has to be 0. And so, here, once we make y 0, we just have to solve for this x, as I said. And solving will look as follows. So we write negative f of x1 times x2 minus x1. And then divide by f of x2 minus f of x1. And then plus x1, right? And we have successfully solved for this x, which is x hat, our very first estimate. And so this is the big formula that we're going to need for our iterative process in Mathematica. And yeah, this is it. Yeah? Cool. Take care.